All right, here's example 6 where we want to find the greatest and least points for this function. It's a cubic function on the intervals for the domain. X is greater than or equal to -2 and less than or equal to 5. So step 1 is we want to find the derivative function. So we're going to use our power rule. And when we do that, we're going to get 3x squared minus 12x. Step 2, we want to find the critical values for which the derivative function equals 0. So we're going to set the derivative function equal to 0. And we're going to solve it for x. So we have to factor it. So we're going to take out the greatest common factor of 3x. What are we left with? X minus 4. Now we're going to use our zero product property. We're going to set the factors equal to 0 and solve for x. So the first one, we're going to divide both sides by 3, and we get x equals 0. Second one, we're going to add 4 to both sides. So these are considered our critical values. All right, step 3, we're going to use our graphing calculators to sketch this function. So here's your graphing calculator. You're going to type in the function, and we're going to see this curve. So this is the x value -2, -1, 0, 1, 2, 3, 4. And then this curve is increasing, changes direction, decreases. So the local, I should say minimum here, is at -2, and then it increases to the local maximum. Let's change this to minimum. And then there's a maximum at 0, and then changes direction, and another minimum at x equals 4. All right, what you can do next is you can evaluate the original function at those critical points. So if we evaluate for 0, so 0 cubed minus 6 times 0 squared plus 5, we get 5. So we go back to that graph. I'm just going to delete this out here. This ordered pair right here is over 0, up 5. That's a local max. And remember, we had those critical points. This was a critical point at x equals 0. And then we had a critical point when x equals 4. So if we go back, we want to find out those local minimums. So we're going to evaluate the original function. So we're going to say f of -2. So you substitute -2 into the function. Use your order of operation, and you get -27. Continue on for f of 4, and then we'll go back and look at the graph. So you evaluate the original function, use your order of operations, and you get -27. So both of them were the same number. So these are both local minimums. So what is that order pair? Over 4 down -27, I should say minimum. And then here is the order pair -2, -27. So those are both local minimums.